Hello everyone! Thank you for joining our webinar for cloud-based simulation of pedestrian comfort for health impact assessment and architectural planning. My name is Veselina Mireva and I am the Principal Project Manager of SoftSim Consult, a small consultancy located in Bulgaria. In the current webinar are presented the efforts of ENGYS, HLRS and SoftSim, completed as a part of EU-funded projects for the development of cloud-based capability of small and medium enterprises called Fortissimo. A series of tasks was performed to develop and validate a new multi-instance framework to support small and medium enterprises, SMEs within urban physics modeling activities and services. As most of you know, ENGYS is a global CFD product and service provider. They were founded in the UK back in 2009. The products are widely used in various industries, including automotive and AEC sectors. Helix is the main product of ENGYS. The tool provides an easy-to-use GUI and unlimited scalability, and it is well validated with reliable methods and fully transparent. Furthermore, Helix comes in a package with extensive written documentation and responsive technical support. SoftSim is a global provider of CFD analysis and consultancy services. We were founded in Bulgaria back in 2014. The company strives in AEC sectors, in particular urban physics modeling. Key services include wind microclimate modeling, pollutant dispersion and air quality, urban environment modeling, and thermal comfort. The main objectives of the current webinar are an overview of the Quad Sophia project by going through a discussion for AEC and UPM industry challenges, Fortissimo project motivation and details, and as well as the main conclusion drawn during project and development works. To understand the motivation behind the work, we need to say a little about the AEC sector and UPM industry. Architectural engineering and construction design are going through a rapid transformation to undergo the transition to a digital era. This pressures design teams to use more advanced modeling tools in the BIM process. This is particularly true for urban physics modeling. SoftSim consultancy is thriving in the urban physics modeling sector together with many other small and medium wind engineering consultancies. Competing with large companies with complete engineering cycles services embedded in their structures becomes more demanding for high quality and fidelity CFD modeling and services. Some of the main challenges in the industry are rapid digitalization of the sector, demanding regulations, and constant growth of customer expectations. Again, this puts the need of high quality and fidelity of the CFD modeling and services in the urban physics sector. All this emphasizes the need for larger computational resources and analyst expertise within the smaller wind engineering consultancies. Small and medium consultancies start to struggle to compete with larger companies in the market. As a main driving force for most cost-effective solutions, without SMEs, entire architecture, engineering and construction would be put under high pressure. This way, the main objectives of the current work can be clearly stated. Meet the industry's demands for high-fidelity products, help to SMEs to keep up with the competition, provide required means for constant and sustainable growth of SMEs. There are four main stages of the standard workflow to deliver urban physics modeling services. These include geometry preparation, computational model setup, flow solution, and analysis and reporting. With the proposed new multi-instance framework, improved post-processing features, and capabilities of the block-coupled solver are targeted sensible improvements in the workflow processes. The proposed solution includes the development of a comprehensive UPM solution based on enhancements in the CFD software, verified automated workflows, and on-demand HPC resources. Through all these enhancements and HPC resources, modeling more complex flows in large-site models would be feasible for any small wind engineering company. Furthermore, this would impact the turnaround times, giving the required means for competing with larger consultancies on the market. In the Cloud Sophia project were completed four sequential tasks, including new methodology development, deploying Helix on the HPC facility, validating and verifying the multi-instance frame code with experimental data, and finally applying the new multi-instance framework for large full-scale site located in Sofia, Bulgaria. In the current webinar, the attention will be focused on the full-scale application. The site encompassed a 4 square kilometer area at the existing city center of Sofia, centered at the Alexander Nevsky Cathedral. A wide variety of numerical modeling of the site were completed. This way, two numerical discretization schemes were developed, depending on the local mesh refinement's requirements. These computation meshes were with various parameters and sizes from 170 million to 190 million cells. Wind microclimate simulations were completed at every 10 degrees of the approaching winds with 5 different atmospheric boundary layer setups. With one rotation, it was completed pedestrian comfort and safety assessment, mean pressure facade analysis, and wind-driven rain and water accumulation analysis with the Eulerian modeling approach. Pollution dispersion analysis was completed in separate runs for the prevailing wind sectors. It assessed the impact of small-sized backup power generation engines sparsely located in different buildings around the target site of the Alexander Nevsky Cathedral. In summary, the entire set of simulations was successfully completed for less than 48 hours, with total output data of approximately 5 terabytes. A total of 50,000 core hours were spent. Main technical achievements for completed development include a complete HPC-based urban physics modeling solution, development of advanced algorithms, introduction of automated workflows, which integrate best practices, and last but not least, a user-friendly environment through the development of the graphical user interface. All these allow unlimited scalability of the project works, the enhanced software product, and streamlined processes, which can reduce sensible turnaround times and competitiveness of the SMEs consultancies. Summarizing the operational benefits to all users, more and more complex models can be constructed and tested, faster turnaround times for the projects, reduced operator skill requirements, improved analyst productivity, easy of use GoE and CFD modeling environment. Strategical benefits for SoftSim in the results of the Cloud Sophia projects are ability to take and work on more complex lucrative projects, this way increasing the company revenue, sensible reduction of the operational costs and thus increasing the profitability, creating more sustainable company environment by expanding the staff and improving the sales and marketing capabilities. Looking for a wider impact on the UPM and AEC industry, Cloud Sophia has offered a reliable and efficient process chain for urban physics modeling, a platform for experts to add value to the design, a more competitive, resource-efficient, and sustainable AEC sector by impacting all processes of urban physics modeling. Take-home messages of the current webinar are the answers to the following three questions. Has the challenge been addressed? Was cloud-based HPC required to address the challenge? Have the partner SMEs become more competitive? Yes, the challenges related to SMEs wind engineering consultancies were successfully addressed. The cloud-based HPC is only one viable solution for the large-scale site assessments. And yes, SoftSim became a more competitive SME consultancy and has demonstrated a constant growth, exceeding 50% for the last 2 years.
I hope you all enjoyed the webinar today. I would like to thank Dr. Vasilina Mireva from SoftSim for her informative and engaging presentation about this amazing project that ENGYS was glad to participate with SoftSim. I know that many of you may have a lot of questions. I kindly ask you to send your questions to my email, which is on the screen, and I will forward your questions to Dr. Mireva so she can get back to you as soon as possible. Thank you for attending this webinar, and I hope you found it helpful as much as I did. Thank you again, Dr. Mireva.